In the animal kingdom, few creatures command as much fear and fascination as the snake. But within this cold-blooded family, a deep evolutionary divide exists. On one side, you have the king cobra, armed with a chemical weapon so potent it can take down an adult elephant in a single bite. On the other side, you have the garter snake or the massive anaconda, creatures with zero venom, completely harmless to humans or relying entirely on brute strength. Why did nature grant some snakes the ultimate chemical death sentence, while leaving others to hunt without a single drop of poison? Today, we are breaking down the fascinating evolutionary war between venomous and non-venomous snakes and the incredible survival science that shaped them. To understand why some snakes are venomous, we first need to look at what venom actually is. Venom is not a single chemical. It is a highly modified form of saliva, packed with a complex cocktail of proteins and enzymes. Snakes didn't just wake up with it. It took millions of years of evolution to perfect. Venomous snakes generally use one of two terrifying weapons. First, there are neurotoxins, used by cobras and mambas. These toxins launch a direct attack on your nervous system. They block the chemical signals between your brain and your muscles, causing rapid paralysis. Within minutes, your diaphragm stops moving, and you suffocate while fully conscious. Second, there are hemotoxins, favored by vipers and rattlesnakes. Instead of the brain, they target the blood. They melt blood vessels from the inside out, destroying red blood cells and causing massive internal bleeding. For a snake, this venom isn't just for killing. It's a predigestive juice that begins breaking down the prey before the snake even swallows it. So, if venom is such an effective weapon, why did some snakes abandon it or never evolve it at all? The answer lies in efficiency and biology. Evolving and producing venom is incredibly expensive for a snake's body. It requires a massive amount of metabolic energy to create those complex proteins. If a snake misses its target, it wastes precious energy. Non-venomous snakes chose a different path of engineering, brute force and speed. Take constrictors like pythons and boas. They don't need venom because they evolved pure muscle. They strike, grab the prey with rows of backward-curving teeth, and wrap their bodies around it. Every time the prey breathes out, the snake squeezes tighter, shutting down the prey's blood circulation to the brain within seconds. Other non-venomous snakes rely on lightning-fast speed to swallow prey alive. For them, spending energy on venom glands is simply a waste of resources. Nature favored their strength over chemistry. Millions of years ago, all snakes shared a common ancestor. But as they spread across the globe, they faced different environments and different prey. This created a fork in the evolutionary road. Snakes that lived in environments with fast, agile, or dangerous prey, like rats with sharp teeth or birds that could fly away, needed a weapon that could disable the target instantly without a physical fight. For them, a venomous bite was the perfect solution. It allowed the snake to bite once, step back safely, and simply wait for the poison to do the work. However, snakes that hunted smaller, slower, or softer prey, like frogs, earthworms, or fish, had no use for venom. A non-venomous snake could easily overpower these targets with speed alone. Over generations, the snakes that didn't need venom lost their venom glands entirely, while those that relied on it developed highly advanced delivery systems, like the hinged fangs of vipers. A split-screen macro photograph showing a direct side-by-side comparison of two snake heads. On the left, a venomous pit viper with a highly angular, triangular head, a visible heat-sensing pit, and a sharp, vertical slit pupil. On the right, a harmless garter snake with a smooth, rounded head and a clear, round pupil. Bright, studio-style lighting for perfect scientific clarity and contrast. Whether armed with deadly chemistry or incredible physical power, both venomous and non-venomous snakes are vital components of our ecosystem. They keep rodent populations in check and maintain the balance of nature. Venom might be terrifying, but it is also saving human lives today, as scientists use snake venom proteins to develop new medications for heart attacks and high blood pressure. Nature didn't make some snakes evil and others good. It simply gave them different tools for the exact same job. Survival. What's the most common snake in your home state? Let me know in the comments below. If you loved this deep dive into evolutionary science, hit that like button, share this video, and subscribe for more mind-blowing nature breakdowns. Stay safe, stay curious, and I'll see you in the next one.